Let's talk about naive Bayes. How does it work? Why is it so naive? And how can you build a machine learning project using it? Picture this. You wake up to the sound of your phone notifying you of a recent message. But instead of opening the text message, you glance at the preview on your phone's home screen and try to guess who texted you. It's 7:12 in the morning, there's a calendar link attached, and the first words are quick question. Your brain starts matching this to what usually happens. Your mom might have texted you early, but your manager is usually the one to send you calendar links. But the important thing is, even before you get too deep into it, you still have a pretty good base rate for who texted you based on your past experience. In statistics, this base rate is called the prior, but we'll get back to that. This is where you start thinking. Your first step is to start with those base rates we just talked about. You give each person a starting score based on how often they text you overall. 40% for your mom, 35% for your manager, and 25% for your friend. The next step is to take one clue at a time. You can think of each factor in this situation as a clue. So you ask yourself, how common is this clue for each person? 7 a.m. texts are common for your mom, less common for your manager, and not common at all for your friend. Calendar links are very common for your manager, but very rare for your mom and friend. The opener text quick question is fairly common for your manager and less common for your mom and friend. The third step is to judge each clue on its own. Now, we do not try to connect the facts that the text was sent at 7 a.m. with a calendar link, even if they somehow do. This simple independence rule is the naive part of naive Bayes, and it keeps the model fast and runnable with small amounts of data. The fourth step is to combine everything. You stack the strength of every clue for each person on top of their base rate. Lastly, you compare those final scores and the highest score wins. That is now your updated belief. In this example, you now believe that your manager has texted you and you need to get up out of bed. In statistics, this updated belief is called the posterior. And that is the whole idea of naive Bayes. Your updated belief comes from your base rates plus the evidence from each clue combined in a simple way. But before we get coding, a quick reality check. Let's say that we decided that another one of our clues was invite attached, which is basically the same thing as saying there was a calendar link. The naive Bayes simple independence assumption lets both of these clues vote, which is basically like letting one of the clues vote twice. This can make the model overconfident, but even so, with quick classification text, naive Bayes is a very strong baseline. Now here's a tiny machine learning version that you can try in Python. We start by opening our coding environment and importing our libraries. In this case, it's 3 tools from scikit-learn. The main pipeline tool lets us connect the preprocessing and the model itself together. Count Vectorizer will turn text into numbers. And multinomial NB is the naive Bayes classifier. Next, we define a tiny training set called text. Each string is a short preview message like something you would see on a lock screen. Alongside that, we create labels, which is the correct sender category for each message, friend, manager, or parent. These two lists line up index by index. The first text message belongs to the first label, the second to the second, and so on and so forth. This is how the model will learn the relationship between the text messages and the sender so it can use that information later. Next, we build the model pipeline in one line, and this does 2 things. First, Count Vectorizer learns a vocabulary from all of the training texts and converts each message into a sparse vector of word counts. Second, multinomial NB learns probabilities from these counts. It tracks how often each word appears for each class plus the overall frequency. When we fit the model, the pipeline runs end-to-end on the training data. And the naive Bayes goes through the exact thought process that you and I went through. After training, we create a new sample message to test the model's skills on unseen data. And for this message, it looks like our predicted class was the manager. And that's naive Bayes for you in its simplest form. If you learned something from this video, don't forget to save it for the next time you're working with naive Bayes and follow for more.